All right, guys, let's look at our Chapter 7 review for our exam. So the first question we have is solving a system of equations by graphing. So remember, we learned how to solve by graphing, substitution, and elimination. Solution equals intersection. So if we're going to solve the system by graphing, does not matter to me if you graph by making an XY chart and finding your X and Y intercept, or if you graph by putting it in slope-intercept form and starting at your y-intercept and then counting your rise over run, whatever you like better. So for this first one right here, x plus y is equal to 4. If I put 0 in for that x right there, that would be 0 plus y equals 4, so y equals 4. And then if I put 0 in for this y right here, that'd be x plus 0 equals 4, so x equals 4. So I've got the point 0, 4 and the point 4, 0, and I could draw that line. So that's the line x plus y equals 4. If instead you wanted to put it in slope-intercept form first, that means you'd get y by itself. So you'd have to subtract x from both sides, so that'd be negative x plus 4. So my slope would be negative 1. And my y-intercept would be 4. So I'm going to start at my y-intercept. So I'm going to start right here at 4. And then my slope was negative 1. So any whole number, if you write that as a fraction, that would be negative 1 over 1. So I'm going to rise a negative 1 and run a positive 1. So from right here, rise a negative 1, run a positive 1. Rise a negative 1, run a positive 1. Rise a negative 1, run a positive 1. So you can see that's giving me that same line. Okay, then the exact same thing with 2x minus 5y equals 15. When I put 0 in for x, I got negative 3 because this whole piece becomes 0. 2 times 0 would be 0, so that drops out. So if negative 5y equals 15, divide both sides by negative 5, and y would be negative 3. If I put 0 in for y, I get this fraction, and that's a little hard to draw. So I did go ahead and plot another point, and I gave you a couple of different ones to choose from here that gave you nice, clean, whole number answers. Again, your other option would be to solve for y, so I would subtract 2x from both sides, and then I would have to divide by negative 5. Now remember, it's what you do to one side, you do to the other side. If you divide this by negative 5, you have to divide this whole side by negative 5. So that's negative 2 divided by negative 5, so positive 2/5. And positive 15 divided by negative 5, so negative 3. So again, for that one, either way you want to go, you can plot your points, or you can start at your y-intercept of negative 3 and rise to run 5. So that would give us our other line. This is the 2x minus 5y equals 15. So this one point of intersection right here, 5, negative 1, is my solution, because remember, solution equals intersection. You also could check this. Now, don't check it while you're working the problem. Like, if you have extra time at the end of your exam, then go back and check. But to check this, I would put 5 in for x and 1 in for y. And I'm sorry, negative 1 in for y, because that was the solution we got, right? 5 in for x, negative 1 in for y would give me 4. And then if I put 5 in for x and negative 1 in for y, you can see that over here. 5 in for x and negative 1 in for y does give me 15. So since when I plug that ordered pair back into both of those equations, it works in both of those equations, that is the solution to my system. All right, let's look at the next one. So for the next one, we've got y is equal to negative 3. Anytime you have y equals a number, it is a horizontal line. So this is just going to be a horizontal line through negative 3. So you can see that right down here. If you made an XY chart for that, it doesn't matter what you put in for x, you're going to get negative 3 for y. So that would be like 0, negative 3, negative 1, negative 3, 1, negative 3, negative 2, negative 3, 2, negative 3. Like that would still give you that line even if you plotted points. Same idea, anytime you've got x equals a number, that is always a vertical line. And so x equals 4 is going to be right here. So again, if you made an xy chart for that, you could put any y value in you want, and x is going to be 4. So that would be like 4, 0, 4, 1, 4, 2, 4, negative 1, 4, negative 2. The other way that we remembered this is, remember that in terms of is it going to be x equals or y equals, it's what it crosses. So when you draw a vertical line that crosses x, it's got to be x equals. When you draw a horizontal line that crosses y, it's got to be y equals. So solution equals intersection. There's my 1 point of intersection right there. It is at 4, -3, and that would be my solution. The second method that we used for solving a system was by substitution. And remember, on the exam, there will be some of these problems where it tells you you must solve by a specific method. So make sure that you know how to solve by the method indicated. All right, so if I'm solving by substitution, then step number 1, I'm going to solve one of the equations for one of the variables. So you'll notice that it's much easier to solve for this x than any of these other ones because they all have a coefficient. We would get fractions if we solved for those. So I'm going to choose to solve for the second equation for x. So if I take x minus 6y equals 21 and I get x by itself, that just means add 6y to both sides. So I've got x equals 6y plus 21. So once we solve one of the equations for one of the variables, we plug that into the other equation. So I'm going to plug that into this other equation in the place of this x right here. So that's going to be in the place of x, I'm going to put what I just got, 6y plus 21. So now I can say 6 times 6y is 36y, and 6 times 21 is 126. You'll have your calculator on the exam to do those kind of computations for you. 36y and 2y is 38y. So to get rid of the adding 126, I'll subtract 126 from both sides. And that leaves me with 38y is equal to -152. So to get rid of multiplying by 38, I'm going to divide by 38. And again, you can let your calculator do this for you. And that'll give us y equals -4. Now, once you know one of the values, how do you find the other one? You plug it in. And it doesn't matter if you plug into this equation or this equation or this equation. So since I know y and I'm trying to find x, and this is an equation for x, this is the one that I'm going to use. So you can see I brought that right here. And since I know that y is -4, let's put -4 in for y. So we'll have -24 plus 21 is -3. So I'm going to write my solution as an ordered pair. X, y, so x was -3, y was -4. And again, if I have time at the end of my exam, I can go back and plug that into both of the equations and check that it makes them both true so that I know that's my solution. All right, here's another one by substitution. So exact same thing. I'm going to solve for this variable because that's going to be the easiest. So I'm going to solve for y this time. So subtract 5x from both sides and I'll get y equals -5x minus 10. I substitute that into the other equation. So here was the other equation. So we're going to replace y with what it was equal to, -5x minus 10. All right, so -7 times -5 is positive 35x. -7 times -10 is positive 70. So 4x and 35x gives me 39x plus 70. To get rid of adding 70, I'm going to subtract it from both sides. And so that would leave me with 39x is equal to -78. So to get rid of multiplying by 39, I'm going to divide by 39. And then -78 divided by 39, and my calculator would give me -2. So once I know x, how do I find y? I plug it back in, and you can plug it back into this equation or this one, but this is going to be the easiest one. So that's what I used over here. And we just found out that x was -2, so let's put -2 right here. So that would be -5 times -2 minus 10. So -5 times -2 is positive 10. 10 minus 10 is 0. So there's my solution, -2, 0, that I write as an ordered pair in my answer blank. All right, then the third method that we had for solving was elimination. And so if I solve by elimination, my goal is to get one set of my coefficients to be opposites of each other. So like over here, if I added the 2x and the x, I'd get 3x. Those don't eliminate. But if I add -3y and positive 3y, that gives me 0y. They eliminated each other because the coefficients were opposites of each other. So if I go through and add here, I'm going to have 3x, 0y, and 3. So if I divide both sides by 3, I'll get x is equal to 1. And then once you know one of your values, like once you know x, how do you find y? You just plug it back in. And you can plug it back into either one of these equations, whichever one you like better. I picked the first one, you could have picked the second one. We know that x is equal to 1. We just got that right here. So if x is equal to 1, then we can say 2 minus 3y. So to get rid of that adding 2, I'm going to subtract 2 from both sides. So then I'd have negative 3y equals 21. Divide both sides by negative 3, and I would get y is equal to negative 7. So my solution would be 1, negative 7. Now, they won't always set it up for me so that my coefficients are opposites of each other. You'll notice down here, if I added, I would get 4x minus 3y, like nothing eliminates. And so my goal is to get either my x coefficients to be opposites or my y coefficients to be opposites. So you could either multiply this top equation by negative 3, or you could multiply this bottom equation by negative 2. So if I did negative 3, that would make my x's opposites. If I did negative 2, that would make my y's opposites. So I'm going to do what I do to one side, I do to the other side. That means every single one of these is going to get multiplied by negative 2. So negative 2 times 3x would be negative 6x. Negative 2 times negative y would be positive 2y. And 4 times negative 2 would be negative 8. So now when I combine x and negative 6x is negative 5x, 2y and negative 2y is 0y, negative 7 and negative 8 is negative 15. To get x by itself, we'll divide both sides by negative 5, and we'll get x is equal to 3. And once we know x, we can plug it back in to find y. And again, you can plug back into either one of these equations. I picked the top one up here. And since we just found out x was 3, if I put 3 in for x, then to get y by itself, to get rid of adding 3, that's a positive 3, right? To get rid of adding 3, I would subtract it on both sides. That leaves me with a negative 2y. Keep that sign with it. Negative 2y is equal to negative 10. Divide both sides by negative 2. And we'll get y is equal to 5. So there's our solution, 3, 5, that we can write as an ordered pair in our answer blank and check it if we have time at the end. All right, then for number 7, they gave us 4 different systems and they asked us which ones represented parallel lines. Now, there are 2 different ways that you could do this. You could solve this just like we were doing with substitution, elimination, graphing, whatever you like better. When you're solving, parallel lines will get the solution 0 is equal to some non-zero number. You get a non-true statement. So like if I took this first set of ordered pairs of equations right here, and I subtracted this 2x over to the other side so that my x's lined up and my y's lined up and my constants lined up. If you'll notice, the x's eliminated, but the y's did not. Like I get y equals 2. If I plug that back in, I'm going to get an x value. I'm going to get an ordered pair. That's not parallel lines. Parallel lines don't have any solution. So if I went to the next system here and I did the same thing, subtract that 2x over to the other side so that everything lines up, and then I need these to be opposites of each other. So I'll multiply this bottom equation by negative 1. So negative 1 times 2x is 2x, negative 1 times y is negative y, and negative 1 times 1 is negative 1. Now you'll notice my x is eliminated, my y is eliminated, and I was left with negative 8. So when I get a non-true statement, that's how I know that I have a parallel system. So that would be one way you could do it. You also could go back to chapter 5 where we know that parallel lines have the same slope. So the other thing you could do is you could look at this first pair right here and say, okay, this guy has a slope of 2. Let's find the slope of this one. So to find the slope of this one, I'm going to put it in y equals mx plus b, slope-intercept form. I'm going to get y by itself. So subtract 2x from both sides, and then I'd be able to see y equals negative 2. There's my slope right there, mx plus b. So you can see this slope is 2 and this slope is negative 2. Those are not parallel because parallel lines have the same slope. But if I go to this second system, the one that we found out was the answer over here a second ago, If I go to that second system, you can see this one right here, y equals mx plus b. That slope is 2. And if we solve this equation for y, we would add 2x to both sides. So y equals mx plus b. That slope is 2. So if their slopes are the same, then they're parallel lines. You can solve it either one of those ways, whichever one is easier for you. All right, then this last one I'll put in a separate video, but it's just a review of solving systems of inequalities.